This is lesson 2 on trampoline physics. It's called How High Can You Bounce? So the first bit, what are the energy changes when you bounce on a trampoline? Now, whenever you bounce onto the trampoline, you're obviously distorting the surface of the trampoline, and so therefore the material is gaining elastic potential energy. And that, of course, then makes you move, so that's kinetic energy. And then that movement makes you move upwards, so that's gravitational. I'm just going to write GRAV, potential energy. And so those are the energy changes when you bounce the trampoline. So there's a constant change between those. Whenever you gain your gravitational potential energy, then you start moving downwards, so that's kinetic again. And then you hit the trampoline, and that's converted to elastic potential, and then it all starts again. So there's a complete interchange of those energies. Now, how high you can bounce, we already discussed this, will depend on how much restoring force the trampoline itself has to give you whenever you bounce on it, and that of course depends on how hard you actually hit it or what the force is when you hit it. So whenever you jump up higher, what happens is as you jump up high, you gain gravitational potential energy. But the higher that you bounce, the more gravitational potential energy you have, and the reason is because you have got a greater height whenever you bounce higher. So we can calculate how much gravitational potential energy you have due to how high you bounce. So the greater the height, the more energy that you have. And the more energy you have, the higher you bounce. So it's again, it's like a circle. So the next thing we need to do is to calculate gravitational potential energy. And in physics, we have an equation for that. I shorten gravitational potential energy to GPE. And to calculate how much GPE you have, you multiply the mass of the object multiplied by the value of gravity. Now, that's actually called acceleration due to gravity. Acceleration due to gravity. And that's multiplied by the height that you reach. Okay, so what we do is we simplify all those into symbols, and the symbol we use for mass is an M. For acceleration due to gravity, we simplify that to a G, and for height, we simplify that to H. And so we can simplify that whole equation to, and I hope this comes out. I don't think it's going to come out too well. I'll try a darker pen maybe. So we can simplify that to GPE is equal to M, which is the mass, G, which is acceleration due to gravity, times the height. Now, on the Earth's surface, the value of G is always 10. So you'll be multiplying the mass of the object by 10 and then multiplying that by the height that you reach to calculate how much gravitational potential energy you have. So now we've got a couple of examples. And if you want, after you see the example and you read the example, take a piece of paper and just write down an answer yourself. Write down the equations, the equation, the numbers, and answer with a unit. And stop the video for a minute till you see how to do it properly. Okay, so this is the answer. So you've got a trampolinist. She's a mass of 60 and reaches a height of 3 metres. And G always has a value of 10. So the equation, you always start with the equation in physics. GPE equals mgh. Put the equal sign underneath the equal sign above. The mass is 60, so write that down underneath. The G value is 10. And the height value is 3. So 60 times 10 gives you 600. And multiply 600 by 3, you get 1800. You could do that on a calculator if you wanted. So the amount of gravitational potential energy that the trampolinist has at a height of 3 metres is 1800, and the unit we always use for energy is joules, capital J. The second example, Again, you can stop the video and do this yourself on a piece of paper and then check the answer. Tom Daly, you may know him, he's a 16-year-old who is a high diver for Great Britain. He's an Olympic diver. He has a mass of 50 kilograms. When he climbs to the top of a 15-metre diving board, how much GPE has he? And again, the value of G is 10. So GPE is equal to mgh, and mass is 50. G is a value of 10, and the height is 15 metres. Now that's a wee bit harder to do in your head, so I would definitely suggest you use a calculator. 50 times 10 gives you 500, and then you have to multiply that by 15, and that gives you in total 7,500. And again, it's in joules. So the amount of GPE you have is 7,000, or that Tom Daly has is 7,500 joules. Now, the next bit is the principle of conservation of energy. And you have to learn this, and it's something that you'll know right up through your school days as you do physics. And the principle of conservation of energy is that energy isn't created anywhere, it's always just being changed from one form to another. And so the way that we describe this, and this is the way you should learn this, and do learn it as a principle of conservation of energy. So it's energy cannot be created or destroyed that's not coming out too well, so I'll try and go over it in black. It is simply changed from one form to another. So you would have done something about the different forms of energy in Year 8 in your Physics Enhanced Performance module, and you've lots of different types of energy. So, but you can't make energy. So that means if you have a piece of coal and you burn it, you've got chemical energy in it, and that chemical energy has been changed into heat as you burn it. So you can't create heat without changing some type of energy from one form to the heat energy. So you need to learn this. Energy cannot be created or destroyed. I'll just go over destroyed, it hasn't come out too well. It is simply changed from one form to another. So fill in the energy flow diagram to show the energy changes as a trampolinist falls. So whenever they're up at a height, they're going to have gravitational potential energy. I'll just write it as GPE. And as they're moving downwards, because they're moving, then their energy is being changed to kinetic energy. Right, so the next thing we have to do is calculate kinetic energy. And again, in physics, we have a formula. And the formula to calculate kinetic energy is that kinetic energy is a half multiplied by the mass of the object multiplied by its velocity or speed squared. So you take the velocity or speed and you have to square that value before you finish your sum. So if we use again an m for mass and a v for velocity or speed, then our equation becomes, and again that's not going to come out too well, so I'll write it with a different pen, Ke equals a half times m times v, and that's squared, half mv squared. So again, we're going to do a couple of examples of these, and feel free to stop the video, try out the sum yourself, and then go back and check the answer. So question 1, a sprinter with a mass of 80 kilograms reaches a top speed of 10 meters per second during a 100-meter race. Calculate his kinetic energy at this point. So again, we're going to start off with Ke equals a half times m times v squared. So that's a half times his mass is 80 and his speed or velocity is 10, but you have to square the 10. So I'll just put another line in here. A half times 80 gives you 40. You only multiply by the half once. It's only in the sum once. You only do a half of something once. So a half of 80 is 40 and 10 squared is 100. And that answer then gives you 4 and 3 noughts, 4,000 joules. And again, if you notice, it's very good to be methodical, to keep your equal signs underneath each other, to keep the numbers from the equation underneath the correct letter, and that will get you your answer. And if you make a mistake, it means you will see very easily where you have made the mistake. A second example then is where you have an aeroplane with a mass of 5,000 kilograms. It reaches a top speed of 200 meters per second during a flight. Calculate its kinetic energy at this point. And again, we're going to write down KE equals a half times m times v squared. That's a half times 5,000 multiplied by, now your v or speed or velocity is 200 and it's squared, so you definitely need a calculator for this. Half of 5,000 is 2,500, and you're multiplying that by 200 squared, and 200 squared is 4 with 4 noughts on the end. That's a big answer we're going to get. So use a calculator, you come up with 100 million joules. Is your answer. So just be very, very careful. It's very easy to lose a knot there. Just be very careful about that kind of sum.